Some of you may be experiencing issues with your Arduino servos when you have them programmed to do multiple commands, like for instance going full speed forward for a set amount of time and then immediately switching to reverse for a set amount of time. Sometimes when you have it do that, it may appear that the servo gets stuck in the forward command, like here. These servos should start spinning in reverse after 2 seconds, however they're stuck going forward. It's as if the Arduino is resetting itself and not able to go to that second portion of your code where you make it go in reverse. The reason for this is that the Arduino can draw only so much power, and when you have the Arduino immediately changing commands to such a drastic extent where you go full speed forward and full speed back, it doesn't have enough power to get it to make that motion to go in reverse. There are a few things you can do to overcome this. One of the things that you can do is actually change your commands to be, instead of full speed, not quite full speed. Because it's full speed 1000 and 2000, that's the range of your servos, the Arduino is trying to power them as much as possible. If you reduce that pulse width to not quite full speed, the Arduino typically is able to handle that, and you will see that it works the way you intend it to work. Now notice here on my sketch to the left of your screen, I'm using the servo library. If you haven't learned the servo library yet, you will learn this in an upcoming class. But you can see that you already know about the pulse widths, and the range is 1000 to 2000, and you can see where I have that written in my sketch. So instead of 1000, I'm going to make this 12,000, and instead of 2000, I'm going to make it 1800. Same thing for the reverse. That allows me to not try and power the Arduino as much, but still accomplish my goal. I'm going to upload this to my Arduino and see if it fixes my problem. And it does. Notice that it's still moving forward and backwards, but maybe not quite as fast. It's still pretty fast, so it will be able to navigate through any particular course pretty quickly. Now, if that didn't fix your problem, another thing that you can do is use a capacitor. The capacitor looks like this. And what a capacitor does is basically it stores charge. So you can put the capacitor on your Arduino, and what it will do when the Arduino runs, it starts to store a little bit of charge. And once it stores that little bit of charge, when you have the Arduino set to go forward and then quickly reverse, instead of not being able to go reverse because it doesn't have enough power within the Arduino, what it does is it uses that little bit of charge that you have stored in your capacitor in order to accomplish that task. Now, it's very important that you pay attention to this capacitor setup, because the capacitor, like the LED, does have a specific orientation that it has to be plugged in. If you look at the capacitor, you can see that there's negative notations on the side of the capacitor. It's the short leg, much like the short leg of an LED. You're going to connect the short leg to ground, and you can see it written on the capacitor. It's very important that you plug it up correctly. If you don't, it can get really hot and potentially explode, and I don't want that to happen for anyone. There's a few places that you can plug this capacitor up. The place that I found is most beneficial if you're trying to get the Arduino to execute the servo commands better is on your power pins of your Arduino. You have a reset pin, and then you also have ground pins. I'm going to remove these pins. I'm going to remove these wires so you can see it a little bit better. So you have your reset pin, and then you have your ground pins. If you take your capacitor and you put the negative side in ground, and you put your positive side in the reset pin, you'll be able to store the charge that you need in order to get the Arduino servos to spin properly. Now notice you still have this ground pin available for your black wire to be plugged into, and you also have your 5-volt power supply as well that you can plug your red wire back into. Now you have your setup, and you're able to plug in your Arduino, and it should turn the servos appropriately. One word of caution: if you do have your capacitor set here between your reset and your ground pin, you'll want to take it out whenever you're uploading any program onto the Arduino. If you don't take it out, the upload will take a really long time or not happen at all. So remember, you can plug it back in, short leg to ground, long leg to reset, and then take it out whenever you're uploading a sketch. Other positions you can put your capacitor is across the power and ground on your bus strip. Remember to put the short leg to ground and the long leg to power. This will accomplish the same goal as putting it in the reset in the ground. In some cases, this may not give you enough charge and you may need to put multiple capacitors. However, using either the reduction of your pulse widths, not having them quite at full speed, and adding this capacitor either on the bus strip or in your reset and ground should accomplish the goal of getting the servos to spin the appropriate way. If you still have trouble getting your servos to spin, please bring your Arduino to your instructor or to the help desk, and we will help you troubleshoot to get your Arduino working the way that it should be. One more note, you do not have capacitors in your kit. If you need to use a capacitor to store charge for your Arduino servos to spin properly, you can get a capacitor in Miss Ashley's office, the Project-Based Learning office, which is IESB 118.